Good morning, class. This is Mo Shahram, and I'm going to guide you how to do your first lab. So let's begin. As you see in your handout, you need to go to this link here and get to the PhET simulation software in order to conduct this lab. So if you look at the simulation, we have different sources that provide waves. You can have a water wave, as you can see here, or you can have a sound wave, or you can have a light wave. So we ask you to choose the sound wave and two speakers that are separated by 200 centimeter. And as you can see, if I turn one speaker, you see the waves propagating in a space. These are sound waves, and they are longitudinal waves. As part of the experiment, you need to find the wavelength and frequency of this wave. Well, there are some tools available to you in this simulation. There's a tape measure here that you can select and basically measure the wavelength of the waves propagated, sound waves that are propagated. So that's the first part. Then you can turn on both speakers that provide sound waves and observe the pattern. These are interference patterns. The two waves are superimposed on top of each other and provide the interference pattern. In order to study the interference pattern, we can look at any point in this space and find out what is the amplitude of the waves that are superimposed on top of each other at those points. So let's take this probe here and let's put one of these probes somewhere here. It asks you to put this about 420 centimeter away from the speaker. So we can measure 420 or close to it, and basically put one of the probes at that point. And you can see how the waves are actually propagating and oscillating at that particular point. And the amplitude of the waves is pretty large. Then it asks you to put another point somewhere in this vicinity here, as you can see in this picture. So let's take that and put that somewhere there. And as you can see, at that point, the amplitude is almost zero. It's not changing, okay? So in this part, you will want to find out what happens at this point P1 and what happens at this point P2. So what you need to do, you need to measure the distances from the first and second source of sounds to those points. So the first, you go here from this speaker, you measure about 433.4 centimeter. And then you can go up there and measure the other one from the center of that speaker to this one, and find out what is the path difference between the two speakers to that point. Then on the third part, you will do the same thing and find out what is the path difference between the speaker at the bottom to that point versus the speaker on the top to that point. So this is basically called delta L, as you can see in this formula. So you find the delta L and process that as it's instructed and find out what is the phase difference and whether you have a constructive or a destructive interference at those points. Okay, so go ahead and try that. You can also try the sound waves or light waves and find out what the points are and what are the wavelengths and so on. So answer the questions on this handout. So go ahead and I will come back and check out with you and check your results and if you have any questions. All right. See you in a little while.